This video will demonstrate my LED flasher circuit. It will include examples of how this circuit can be used and an explanation using block diagrams of how to wire up this board with my block detector boards and solid-state relay boards to drive railway crossing flashers. Here I have hooked up two of my LED flasher circuit boards. The one on the left controlling a set of HO scale railway crossings, and the other circuit board controlling the headlights and roof lights of an N-scale fire truck. I am using a 5-volt power supply as the power into the two boards. Watch as I adjust the small pot on the circuit board feeding the LEDs to the fire truck. This will vary the flash rate of these LEDs. This should give you a good idea of the range of control you have over the flash rate of these LEDs. You could also use a 9-volt power supply to drive these boards with no changes. The LEDs would just be a little brighter. To use a 12-volt power supply, you would either have to change the two 470 ohm resistors on the board with maybe something like 1K resistors, or add two 470 ohm resistors to the outputs in series with the LEDs. You can see how I do this on the block diagram I included. This next clip shows a locomotive driving down the line of my demo layout. Notice when the loco enters the block with the railway crossing, the LEDs start flashing, and stop when the loco leaves the block. Here is a picture of my flasher circuit with two solid-state relay boards. Two relay boards are used here because the road crosses over two blocks. You will see a diode connected to the output of each relay board feeding the flasher board. This is to prevent one board feeding back into the other board. Now, using a block diagram, I will show how the LED flasher board can be hooked up to one solid-state relay board and one of my block detector boards. When the train enters the block with the railway crossing, I use one of the green LED outputs of the block detector for that block, in this case B2G, to switch on one of my solid-state relay boards. I feed plus 5 volts to the supply input of this board. And when this board is switched on, it feeds this plus 5 volts through its outline to the plus 5 volt power input of the flasher circuit, turning it on. The output of the flasher circuit feeds the LEDs of the railway crossing, causing them to flash back and forth. The solid-state relay board is needed because the green LED output of the block detector does not have enough current capability to power the flasher circuit. Either of the green LED outputs, B1G or B2G, can be used even if they are already feeding LEDs of the block singles. So this is it. To find out more information on this board and my other circuit boards, check out my block detector block single demo video on YouTube.